The Fukushima nuclear power station features what we call a boiling water reactor. It has the two water circulation loops. One is the cooling water system. Cooling water is from the sea, so that explains why the station is located at the seashore on the coast, because the power plant needs the cooling water for the cooling. So why does it need the cooling? Because the other loop or the other water circulation will feed into the reactor. The water goes into the reactor. The reactor, because of nuclear fission, will generate a lot of heat. The heat will boil the water and convert the water into steam. The steam will then go to drive the steam turbine, generate electricity. The steam will then be condensed by the cooling water, meaning the seawater, the cooling seawater, condense it in the water, and the water will go back into the reactor. The reactor will again boil the water, so to speak, convert it into steam. Steam will go back to generate electricity, and then will be condensed into water. Water will go back into the reactor. Reactor will again convert the water into steam. Now, the important point here is because the water actually goes into the reactor and becomes steam. So the steam will be very close to the reactor, actually adjacent to the reactor. So as a result, the steam would carry radioactivity coming from the what we call nuclear fuel bundle, which consists of uranium and plutonium and so the steam is contaminated with radioactivity. So this time when we have this serious accident at Fukushima because of the loss of coolant, the loss of cooling water from the sea because of the tsunami. The tsunami destroyed the cooling water system. No more cooling system. So it's almost like you're driving a car and then you suddenly lost your cooling water. So the engine will become hotter and hotter, and the steam would will be coming out of the engine. Similar case. So in Fukushima, when the Japanese worry that the steam becomes so hot and it might cause the reactor to melt down and then cause an explosion, almost like the Chernobyl accident in the former Soviet Union. So they worry about that. So they let the steam off. But the steam, as I explained, carries radioactivity. So the radioactivity quickly spread into the sky and then spread all over the place. And now you heard that it was a lot of radioactivity coming into the air as a result of it. I think originally they didn't know how much. Now they know it was a very large amount of radioactivity coming out with the steam. So that's the tragedy of the Fukushima. A Daya Bay is a different kind of reactor. It's called pressurized water reactor. In short, PWR, whereas the Fukushima is called boiling water reactor, BWR. The pressurized water reactor has three separate loops of water circulation. The first one is the cooling water from the sea, same as the case of Fukushima. But then, in addition to the cooling water system, there are two other systems. One is the water going into the reactor, and then the nuclear fission would generate a lot of heat and heat up the water. But that water loop would not convert into steam. It just carries a lot of heat, and then it will carry the heat outside of the reactor, and then will transfer the heat into the steam system. The steam system is the third system outside of the reactor, totally independent of the reactor. So we have altogether three separate water loops or water circulation systems. One, the cooling water. The second one, the one in the reactor would absorb the heat, but then that circulation of water would go outside of the reactor, and then at a heat transfer interface outside of the reactor, the heat will be transferred to another loop of water, and that will convert into steam. But because of the steam conversion or steam generation is totally outside of the reactor area, the steam would not carry radioactivity. So in that sense, Daya Bay is better. Even if you have something like Fukushima happening at Daya Bay, you have to let the steam off. The steam would not be radioactive. It would not carry radioactive material. It would not end up with a situation like Fukushima, Japan. So this is the basic difference.